Okay, so very good afternoon to all. I welcome you for the next bit of this particular design calculation. After beam strength, the main important consideration in this is wear strength. So, wear strength. When the contact stresses between two meshing teeth exceeds the surface endurance strength of the material, the wear failure or pitting, surface wear, scratches, etc., it will start. We have already discussed there are, I think, certain causes in this, causes and remedies. So we have discussed five different types of wear failure. Just I want to remind you that we have discussed these five different types of wear failure. So there may be, first you can say abrasive wear, then corrosive wear, then initial pitting, then destructive pitting and scoring. And particularly in destructive pitting, we have discussed that when the total load or contact stresses between the teeth exceeds the endurance strength of the material. See here, exceeds the endurance strength of the material, then wear will start. So we have to take in account this also. And if you see in new practical also, there are very less chances that the gear will fail due to beam strength. If all factors are considered in account, then there are very less chances. But there are more chances, maximum probability the gear failure due to wear strength only. So, and wear strength, the one criteria considered. So every time not it is mentioned that wear. So in definition also, it is the one criteria is considered. Destructive pitting also started by a small pit. So this word is continuously used in pitting. So it is failure due to pitting. So pitting is a surface fatigue failure characterized by small pits on the surface of the gear tooth. In order to avoid this type of failure, the proportions of gear tooth and surface properties, such as hardness, should be selected in such a way that gear tooth is more the effective load between the wear strength will be more so that it can tolerate the effective load and there is not failure occur due to this wear. So small pits are occurring and the small pits, whatever generation of small pits will be there and the small pits will lead to destructive pitting. And in order to avoid this, we have already discussed that in order to avoid the small pitting, the surface endurance strength should be high. And sir, how the surface endurance strength should be higher? So first is selecting a material having good surface hardness. So first is selecting a material having good surface hardness. And if the good surface hardness is not there, then again we have also discussed there one can go for the second point is one treatment increasing the surface hardness. So you can any if depending upon the requirement, so one can go for the case hardening treatment also. So what you will get here in this case hardening treatment, the case hardening, the inside core part will be remain tough and ductile to absorb the shocks and the outside part will become hard so that the endurance strength of the material will be hard and there is good wear resistance produced by this particular treatment. Okay, so the analysis of wear strength was done first by the Earl Buckingham. The analysis made by this Buckingham. Therefore, in the paper, the relation of load to wear of gear teeth submitted to AGMA, American Gear Manufacturing Association in 1926. So now also whatever wear strength equation is there, it is called as Buckingham's equation or Buckingham's equation for wear strength. So wear strength, it is the when the failure will occur due to surface destruction or due to pitting, due to surface wear, it is considered under wear strength. The first time analysis of this strength was made by Earl Buckingham. Therefore, the equation is called as Buckingham's equation for wear strength also. And in order to avoid this failure due to pitting, the surface hardness should be more. Selecting a material so that the surface hardness should be more. Or second case, one can go for, if possible, then case hardening treatment also. So these are the some of the pointers in this. Now let us discuss the wear strength. Okay, the wear strength is given by, it is written here. So wear strength, let us discuss first definition, then we will proceed further. The wear strength is the maximum value of tangential force that the tooth can transmit without pitting failure. Without pitting failure. So in last case, we have also discussed the definition. So what was the definition we have discussed last time for bending? So it is the case that here I am highlighting the word pitting. So the beam strength is the maximum value of tangential force that the tooth can transmit without bending failure. And here the word is clear cut mentioned without a pitting failure. So here the failure is due to pitting. And whatever the maximum tangential force it can transmitting, so that there will not be pitting occurs at all, the strength is called as wear strength. So it is given by formula SW is equal to BQ SW is equal to BQ SW is nothing but the wear strength in Newton. B stands for, here it is not mentioned, so I will write B stands for the face width. B stands for the face width in millimeter. If it is not given, then we will consider in the analysis face width as 10 times of module, and module is in millimeter. Okay, this is the additional part that I am telling to you. Then what is Q in this case? Q is the ratio factor. Q is the ratio factor. dp is the diameter, pitch circle diameter for pinion. And what is K? K is the load stress factor. So K is the load stress factor. So again, we will discuss. So I request you all to write down this equation as wear strength equation. So wear strength is given by Earl Buckingham, and the equation, yes, W is equal to B Q dp k. So BQ dp k. Just I have given you idea. B is the face width. In millimeters. Q is the ratio factor. What is Q? Q is the ratio factor. Again, there are two parts in this Q. So Q is given by twice ZG divided by ZG plus ZP, and twice ZG divided by ZG minus ZP. Twice ZG divided by ZG plus ZP. And again I will write also Q is equal to twice ZG divided by ZG minus ZP, where ZG stands for number of teeth on gear, ZP stands for number of teeth on pinion. And the formula, why there are these two different formulas? So you can say here one part is external, another part is internal. So I can show here like this. So when the gears are, this formula we will apply when the gears are external, and this formula we will apply when the gears are internal gear, and this external when the gears are external gear. So if ZG and ZP is given, number of teeth on gear and number of teeth on pinion, very easily we can calculate the value of Q. The Q is nothing but the ratio factor. So SW is equal to B discuss, Q discuss. What is DP? It is a pitch circle diameter of pinion. Pitch circle diameter of pinion. And what is K? K is nothing but the load stress factor. So K I can write down as a load stress factor. So again, K is having two different formulas. So this is about the wear strength. I will highlight this wear strength as the wear strength. It is the definition. The wear strength is defined as the maximum tangential load that the tooth can transmit without a pitting failure. So this is wear strength. And SW it is given by SW is equal to BQ dPk. So this is the formula, and we have discussed just now. B is the phase width, Q is the ratio factor. The ratio factor having two different formula. The external gears twice ZG divided by ZG plus ZP. Internal gears twice ZG divided by ZG minus ZP. In this way you can calculate Q. Then dP, piece circle diameter of pinion, and K is the load stress factor. So let us discuss what is this load stress factor. So K is nothing but the load stress factor. This is the theoretical formula. Sigma C square sin alpha cos alpha into 1 upon E1 plus 1 upon E2 divided by 1.4 divided by 1.4. This is the pure theoretical formula where sigma C is the endurance strength of the material. Sigma C is the endurance strength of the material in Newton per mm square. Alpha is nothing but the pressure angle, and E1 and E2. E1 and E2 modulus. So I can call it as moduli of elasticity. Moduli of elasticity for pinion and gear material. Okay, so what is K? K is nothing but the load stress factor. The different things are given like this. See here. Sigma C is the surface endurance strength, alpha is the pressure angle, and E1 and E2 are the modulus of elasticity or moduli of elasticity for pinion and gear material. If you will substitute all these values, then you will get the value of K. This is the, we can say, theoretical or generalized formula. Theoretical or generalized formula. Now, generally, our gears are made up of steel material, and generally the maximum pressure angle is 20 degree. So by considering the gears are made up of steel material, it is mentioned here both the gears are made up of steel material and with 20-degree pressure angle. If we will substitute these values, that alpha is equal to 20 degree and E1 and E2 values for steel material. So it is approximately 206 into 10 raised to 3 Newton per mm square. So we have used in analysis of mechanical elements also number of times. 2 into 10 raised to 5, 2.1 into 10 raised to 5. So same value, 2.06 into 10 raised to 5 or 206 into 10 raised to 3 Newton per mm square. So if I will substitute in the formula, then finally I will arrive at, finally, this is the formula you require most. Finally, I will arrive at K is equal to 0.16 BHN divided by 100. So load stress factor is given by K is equal to 0.16 into BHN divided by 100, where BHN stands for the Brinell hardness number. So from where it is in the picture, it is in the formula of sigma C. It is in the formula of sigma C. So when it is mentioned clear cut in the design consideration or data that the gears are made up of steel material, and 20-degree pressure angle is there. 20-degree pressure angle is there. Directly I will use the formula. This formula I will prefer directly. K is equal to 0.16 into BHN divided by 100 square. This formula I will use directly. I will not go for whatever this generalized formula is mentioned here. Okay. So this is the discussion what is required about the wear strength. So wear strength in this way we can calculate. Once again, I will take back wear strength. Yes, W is equal to BQ dPk. B face width, Q ratio factor we have discussed, dP, pitch circle diameter. And for load stress fracture, we have made this discussion. And in this way, you can calculate the K and the K value. And the K value, if you will put, then you can easily calculate the SW. That is wear strength of the material. Okay. So I will give you some time for these two slides, 2 minutes. If anything is missing, please write down formula. Then we will proceed further. Wear strength formula. BQDP, three factors are discussed in this slide. And the load stress factor K, it is mentioned here. Okay, let us move next. Very, very important part in this consideration. What are different steps? So, this is the additional part which is required for solving the numericals based on the calculation of module. These steps are required. So after this, we will be starting about how to, first we will go for 2, 3 simple numericals for force analysis, and then we will proceed further for the module calculation based on beam strength, wear strength, and also we will be discussing about the different, if all the things are given, then how to calculate. If module is given, then how to calculate the power transmitting capacity, KW, beam strength, wear strength, effective load, based on all these things we will calculate. So there are these two different aspects. Module is given, all other things are asked to calculate, or additional data is required, whatever required is given, and we have to calculate module. So these are two different aspects of designing these particular gears. So next is steps for calculating module. Very important. What are the different steps? So very first step, calculate the torque transmitted MT from the power formula. Calculate the torque transmitted by using the power formula. What is the formula here we are having? We have already discussed MT is equal to 60 into 10 raised to 6 kilowatt divided by 2 pi n. If I will substitute in this formula kilowatt value, then I can easily calculate the value of MT. This is our step number 1, to calculate the value of MT in any of the numerical. Okay, then step number 2, calculate the tangential load in terms of module from the torque transmitted. Now we are having MT value. Based on this MT value, we can calculate the value of PT. So we are having formula MT is equal to PT into dP by 2. We are having the formula with us MT is equal to PT into dP divided by 2. So I can write from this, and we are having formula for dP. Pitch circle diameter is given by module into number of teeth. So same it is mentioned here. I will write here dP is equal to module into number of teeth on pinion ZP. Okay, so how I will write PT then? I will write PT is equal to, we are having formula twice MT divided by dP. Putting dP in the formula, we will get PT is equal to twice MT torque divided by dP. I will write as M into ZP. So conversion of this PT in terms of module. See, module is not given. We have to calculate the module. Therefore, one guideline I will give. Whatever PT, then beam strength, wear strength, effective load, everything we will be calculating. We will calculate in terms of module. And in the final stage, we will equate it. And you will get the value of module. So this is the very first thing. So first part, calculation of MT. Second part, calculation of PT in terms of module. Second part, what is mentioned here, this calculation of PT. So PT in terms of module. So if you see here, you can easily highlight this PT in terms of module. This is the value of module. So PT in terms of module. Slowly we are going. It is expected, it is required that if you, this highlight pointers are required with you so that it will be easy for solving the numericals. Okay, so this is the next point. Then calculate beam strength in terms of module square. So calculate beam strength in terms of module square. So though it is written, once again I will write down for a better understanding. So what is our formula? We are having formula SB is equal to MB sigma B into Y is equal to module as it is. Face width is assumed as 10 times of module. So 10 times of module into sigma B we have discussed in the, according to Buckingham's, it is SUT divided by 3. SUT is given and Y is the Lewis form factor. So if you see this particular equation, then you can easily come to know by using this that m into 10m. So it will become 10m square. SUT some value is given. Assume that 600. So 600 divided by 3. And Y value for whatever number of teeth on pinion. So assume that 0.32. So if you will put the value of Y, if you will put the value of SUT, then your equation will get converted as, for your understanding, I am writing SB is equal to, here some value will be there, into module square. So SB will get converted into, SB is equal to some value will be there and into it is written that module square. So this is the expressing your beam strength in terms of module, or I will say in terms of module square. So this is the step number 1, calculate MT. Step number 2, express PT in terms of module. Step number 3, express SB in terms of module. So these are the first 3 steps. That you just take the highlights and the important formulas. Some time I will give to you for this. Oh, okay, so these are the three steps for calculation of module. So torque calculation, tangential load PT calculation in terms of module, and then beam strength calculation in terms of module. Let us move further. Step number 4, calculation of wear strength in terms of module or module square. So see here, what SB is equal to, we are having, I will again explain, SW here, SW is equal to BQ dP into K, BQ dP into K. So B, I will substitute the value of B as 10 times of module in terms of module. Then dP in the is I will dP I will put it as dP value I will put it as M into ZP. Number of teeth are given. Then next Q value I will substitute twice ZG divided by ZG plus ZP. Assuming that number of teeth are given. And if both the steel gear are made up of steel material, then I will use another formula BHN divided by 100 bracket square into 0.16. This is nothing but your value for K. So if you see all these values we are having, this is nothing but your K value. This is nothing but your K value. So K value, if Brinell hardness number is given, Brinell hardness number is given, you can, this value you will get. Number of teeth on pinion and number of teeth on gear are given, ZG, ZP given. You can calculate Q separately and you can put in the formula. Then M into ZP, ZP is given. So what will be unknown for this M and this M? So M square. So again you will get the final answer as, for example, I am writing SW is equal to something into module square Newton. It is strength. Therefore, ultimately unit will be Newton only. Okay. So in this way you can calculate SW. So substituting all the values, once again I will repeat, B is equal to 10 times of module, then dP is equal to M into ZP, Q value twice ZG divided by ZG plus ZP, where ZG and ZP are the number of teeth for gear and pinion respectively, and K is given that where both the gear and pinion are made up of steel material and 20-degree full depth in hollow system. Then in this case K is given by 0.16 into BHN divided by 100 bracket square. So this value also can be calculated. So if you substitute all the values, then only M square will remain as unknown. So we will get SW is equal to something into some value here into module square. So this you will get as the output. This is your step number 4. By substituting all the values, we can calculate SW in terms of module square. So this is your SW. Now, step number 5, compare SB and SW and take the value which is minimum. Now both terms are in module square. So for example, I will write in this particular case, you are having SB is equal to 80.5 module square. This is just example. And SW is equal to 49.3, I will say here, module square. So you have calculated SB and SW in terms of module square. So as I can compare these two values because these two values, the module square and module square is common and the unit is also Newton. Therefore, I can compare. And in this case, assume that time being module is 1, then SB is equal to 80.5, SW is equal to 49.3. So we can clearly say that SW is less than SB. SW is less than SB, and therefore, I will write here wear strength is the criteria for design. wear strength is criterion for design. So in this way we have to proceed. So after calculation, this is just example I have given. So after calculation of SW and SB, the next point is where we can calculate the module based on SW. We can calculate the module based on SB. So which we have to take? So we have to take the minimum. If we will calculate for SW, definitely it can tolerate the conditions for SB also. So whichever minimum we have to take, and therefore here it is mentioned that just sample values I have given. Just sample values I have given. And from this it is you can clearly see that the wear strength is the criteria, and based on the above that SW is lesser than SB, we have gone for comparison. And then I have written here wear strength is the criteria for design. In this way, we have to take a criteria for design, and here wear strength is the criteria. Now step number 6, calculation of effective load. So we have already discussed here effective load is given by P effective is equal to CS into PT divided by CV. CS into PT divided by CV. So here in this case, CS based on the what is problem, CS is given that the maximum permissible torque is 125%, 150% of the rated torque, required torque, like it is given. Therefore, we can say that CS value is 1.25 for 125%, 150% CS value is 1.5. PT we have calculated in terms of module. Step number 2. Step number 2, PT we have calculated in terms of module we are having. Now let us concentrate on CV. This is the approximate estimation method in the precise in the design of gear stage at the early stage. So we are not having all the dimensions. We cannot go for precise calculation. So here we will use the first formula, that is approximate estimation method. So in this case, we have to go for the approximate estimation. Therefore, we have written here, and the formula we have written here. This is the approximate estimation by velocity factor. Now, what is the velocity? Pitch line velocity V is the pi dn divided by 16 to 10 raised to 3. Pi dn divided by 16 to 10 raised to 3. So there are two chances. We have to go for either assuming V is equal to 5 meters per second, or second also we can go for, we have written the formula pi dp np divided by 60 into 10 raised to 3. So either it is given in numerical, if it is, you can assume V, then based on the value of V, you can use the formula for less than 10. This formula I will use for 10 to 20. Second formula I will use, second formula is here. CV is equal to 6 upon 6 plus V. So if V is less than 10 meters per second, I will use 3 upon 3 plus V. If it is 10 between 10 to 20, the pitch line velocity, I will use 6 upon 6 plus V. And if it is greater than 20, I will use the formula 5.6 divided by 5.6 plus under root V. Now, if the pitch line velocities are not given, but it is mentioned that the gears are ordinary and commercially cut, directly by taking the help of this word, you can write the first formula. If the gears are hobbed and generated, if this word is there, you can use the second formula. And if they are precision gear, saving, gear grinding, and super finishing operation are there, you can use this formula. So any one of the formula you can calculate CV, put in the equation, you will get P effective. Again, I will say in terms of module only. So you will get after calculation, this calculation, you will get P effective, very important, in terms of module only, because here for PT module is there, and if the velocity is not given, then again the problem is becoming somewhat lengthy. So pi value no problem, np value is given. If the no any consideration is given, then dp again you take here m into zp. So your v will be in terms of module, and your cv will be in also terms of module, and then P effective also will be in terms of module. So these are the considerations you will get P effective in terms of module. Now, this is the step number 6, calculation of P effective in terms of module. So step number 6 here in this case, the output of the step is I have calculated, for example, P effective in terms of module in this equation. This is our step number 6. Now step number 7, we can say here step number 7, equate P effective to minimum value of ESB or ESW. So equation number 4. Equation number 5, we have written that ESW and ESB comparison, and we have declared that ESW is minimum. So you go for checking, you will go for checking where ESB is minimum or ESW is minimum, and whatever is minimum, you will equate that with P effective, because we are having relation between P effective, ESB, ESW and EFS. We are having P effective, ESB, ESW and EFS. So you will use the relation and you will proceed further, and then now final step you will get easily the module. Final step you will get easily the module. So here in this case, last step I will write here, the last step of this equation. So ESB or ESW. So we are having P effective in terms of module, ESB in terms of module, and ESW in terms of module. So ESB should be greater than P effective, ESW should be greater than P effective. So by what amount it is greater? We have discussed that it is nothing but the factor of safety. So if factor of safety is given, whatever factor of safety is given, then module cube you will get, or you will get an equation, and finally you will calculate the value of module. Finally you will calculate the value of module. So these are the few steps for calculation of this module. When we will be solving problem at that junction, you will again come to know exactly based on the whatever given thing, that how exactly the module is required to be calculated based on beam strain, based on wear strength, how to calculate the effective load. So whatever things are mentioned, definitely you will come to know. Okay, this is about the steps for calculation of module.